Hey, this is Engineering One Help, and this is a little bit of a different video than what you're used to. I'm going to explain vertical circular motion to you in 5 minutes, maybe even less. So bear with me, and it literally only takes 2 examples to show you guys exactly how to solve any and every single question. Please note that you do have to understand basic physics to be able to complete this, but other than that, you should be fine. Now, if we were to draw a circle, a good circle, and we have some object in rotation, right? We say that that is roughly the center. Some object rotating about the center. Oh no, our object's gone. It's okay, we'll just use highlighter. Okay. Some object rotating about the center. We have, I'm actually going to put it up here, we have something called the centripetal force. Why did my circle get erased? This is not going well. Oh well. Okay. This centripetal force points in the center. I'll show you guys. Centripetal force always points towards the center of the circle, and it's denoted as Fc. Then we have our tangential velocity, which always points in the direction. So if our rotation is going this way, it's as if I suddenly let go of this object, and where would it go? This is the tangential velocity. All right? And now this exact problem can be replicated with, let's say you have string. So you have a tension force, T. You have gravity, right? Now, how would I set up this equation? I'm not going to actually solve for any numbers. I'm just going to show you guys the method for setting up the equation. FC, and always draw this diagram if you guys have no idea. FC is always our reference vector. It's always our reference force. So that means whichever direction FC is pointing in, that is going to be positive, right? So FC is always equal to, and then now we take a look at all of our other forces. So we have a tension pointing downwards. Is that in the same direction as FC? Yep, it is. So positive tension. We have gravity, so force of gravity, which is pointing downwards. Is that pointing in the same direction as the centripetal force? Yes, it is, which means plus Fg. And that is literally the entire equation. We take a summation of forces. We do have a velocity here, but it's not a force. Tension is a force, gravity is a force, velocity is not a force. Now, what if, because we are people full of great ideas, what if we have this circle? Okay? And we have the center. And our object was at the bottom. At the bottom. Okay? How would we solve this? How would we solve this? Well, our equation in this case, and I'm going to put it in this blue, FC is pointing in this direction. All right? This is FC. Let's compare all of our other forces. Our tension, since the string is going towards the center, is going to be pointing up. So our T is up. And our force of gravity is down because force of gravity is always down. So that's going to equal to tension minus Fg. Please do know that when you do calculate this, right, it's just mg. The g's are always going to be positive, okay? These signs right here, these little symbols that we add, that's what denotes if it's going to be positive or negative. So don't worry about that, all right? Now, let's say we don't have any tension, okay? And this is where it gets a little bit tricky because this question stumped me when I first saw it. Let's say we have a hill. We have a hill, okay? And on this hill, there's a little car, which at this point just looks like a box with 2 wheels, and we're not judging. Okay, I'm sorry. I needed to sneeze and I thought you guys didn't need to hear that, okay? A small little car. Yay! Family trip, okay? Does this car have centripetal force? Oh, yeah. Oh, yeah, it does. Up, 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 up. To wherever the center is. In this case, I think it'd be about there. Yeah. Right? Maybe a little bit higher. And so it does have a centripetal force. So in this case, what forces are acting here, right? I'm going to use purple now. Our FC is acting in this direction, right? This is FC. We don't have tension. So let's just forget about that for a second, okay? We have a force of gravity that's acting downwards. And do we have any other force? I'm going to bring us back to something. If you guys have not already guessed it, I'm going to give you guys a little bit of a hint. Let's say you have a block sitting on a table. What forces are acting on it? There's mg, and then there is mg. One of them being negative, one of them being positive. This is the normal force. Which way does a normal force point? The normal force always points perpendicular to the plane on which the object is sitting. So if this were the plane, perpendicular to it, up, 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 always in the positive direction. So N, okay? So our FC is equal to positive force of gravity because they're going in the same direction, and negative normal force. And you always set up your equations this exact same way. Now you might be wondering, okay, you can solve for the force of gravity using mg, but you can't solve for tension or for the normal force. And how in the world do we get the centripetal force? They give it to us. Usually they don't. So let you guys in on a little bit of a secret. The centripetal force does have an equation. What is that equation, you may ask? I'm looking through my notes right now. Oh, yes. The centripetal force has an equation of Fc is equal to mv squared divided by r. This right here would be r. V would be your tangential, right? This is tangential velocity. And then your mass is just the mass. Correct? I will upload an example, but that is 5 minutes and we are done.